The next example is from section 4.6, exercise number 8. So analyze and sketch the graph of the function x cubed over x squared minus 9. We start with finding the domain. So we find where the denominator equals 0. And we get x cannot equal positive or negative 3. So that gives us our domain negative infinity to negative 3 union negative 3 to 3 union 3 to infinity. And with that, we also find our vertical asymptotes to be x equals positive and negative 3. Now, since the degree of the numerator is 3 and the degree of the denominator is 2, and so we see that the degree of the numerator is greater than that of the denominator, which means there wouldn't be any horizontal asymptotes. But then, because it is the degree of the numerator is greater than the denominator, what we get is a slant asymptote. And so to find a slant asymptote, what we do is use long division. To divide the numerator and denominator. So we divide x cubed by x squared minus 9. So you see our numerator is x cubed, and we divide that by the denominator x squared minus 9. So x cubed divided by x squared is x. Multiply, we get x cubed. X times negative 9 is negative 9x. Subtract, we get positive 9x. And so the quotient, we now have x cubed over x squared minus 9 is equal to the quotient x, and we have a remainder of 9x over x squared minus 9, which gives us our slant asymptote. Our slant asymptote is going to be the equation y equals the quotient, which is x. Okay, so the next that we will find are the intercepts. The intercepts that we are going to get let me write the function again right here. Remember that it's x cubed over x squared minus 9. So to find an x-intercept, we set this equal to 0. And so what we get is just x equals 0. And if I plug in 0 for x, all I also get is 0. So the only intercept that I'm going to get and it's both an x and y intercept would be 0, 0.